Good evening, everyone. I'm Dr. Sarika Chauhan, Chair of the Program Committee at EdTech Society and Chief Academic Officer at Vidyalankar School of Information Technology in Mumbai. It is my pleasure to welcome you all to the Masterclass 20, How Data-Driven Services Support Technology-Enhanced Education. Before we begin, let me tell you a bit about who we are. EdTech Society is a professional association started in India by individuals who are committed to improve instruction and learning through the use of educational technologies. EdTech Society members are researchers, developers, and practitioners in the field of educational technology. Joining EdTech Society offers numerous benefits like networking and collaborations with experts in educational technologies, opportunities for professional growth, affiliation with international associations, awards, scholarship, and internship programs, reduced registration fees for annual conferences and faculty development programs, winter and summer schools, access to key resources and best practices in educational technology. We also conduct various events like Masterclass, Industry Talk, In Focus Interview, Perspective, a panel discussion, T4E conference, and many more. So join us and unlock a world of opportunities in educational technology. For more details, you can visit our website, etsociety.org. So now, let me introduce our esteemed speaker for today's masterclass. Professor Rwitajit Majumdar is trained as an engineer from BITS Pilani, India, in engineering technology for undergraduate and design engineering for masters. He then completed his PhD from IIT Bombay, working as visual analytics for educational datasets. He moved to Japan in 2018 as a postdoc and then a senior lecturer at Kyoto University. Since 2023, he has been an associate professor at Kumamoto University in the Research and Education Institute for Semiconductors and Informatics. His research interest is in learning analytics and educational technology, focusing on leveraging data-driven solutions to enhance teaching learning experiences and outcomes. His contributions, numerous publications in top-tier journals, and presentations at international conferences have been recognized by early career awards from IEEE and Asia Pacific Society for Computers and Education in 2023. Rwitajit's international collaborative projects often bridge the gap between theoretical research and practical application, providing valuable insights and tools for educators and learners alike. So on behalf of EdTech Society, I extend a warm welcome to our esteemed speaker, Professor Rwitajit Majumdar. We are delighted to have you here today. So before I hand over the session to the expert, there is an announcement for the participants. You can post your queries and questions using the comment section, and the answers will be given towards the end of the session. So now I request Professor Rwitajit to begin the session. Over to you.
Thank you, Dr. Sarika. And before I begin, I really thank EdTech Society for this opportunity. I thank Dr. Birju and Dr. Lakshmi to contact me for organizing this session. And if probably my screen is already visible. Yeah, thank you. So today's talk is, let me see. Oops. Is whether if it is not. Let's try that again. Yes, probably it's there. Okay, Sorry about that. Technology means that there would be technology glitches, but we will live with that. So I happen to be trained from BITS Pilani, and my undergraduate was in engineering technology. It was in ET, and then I ended my collecting of the degrees in educational technology, which was also in ET. So I say that I come from ET to ET, and since 2023 in September, I started as an associate professor in Kumamoto University, and they have a very interesting new program about data science and combining data science and semiconductor engineering. Okay, it's a new initiative, and where I fit in, it's in the School of Informatics. And the School of Informatics, I wear a hat of a design science and a learning analytics researcher, where what I do there is on the research front, we try to build systems that are data driven and can be applied in the educational context. And to build that system, I often co-design with the stakeholders. So for me, the stakeholders are the teachers, the learners, and other researchers who are there in that context. So in today's talk, what I plan is uh, to first say my research focus. It's in an intersection of applying AI and educational data science research, and develop technology based on that, and also not just develop the technology.
Sujit, just sorry to interrupt you. I think you need to reshare your screen.
Oh, okay. I would reshare the screen. Is it visible now?
Yes, perfect. Yes, please continue.
Thank you. Thank you for that. Okay, what you did not see on the screen was this picture of how I moved from which part of India to Japan, and then I was talking about the focus of my research was in the intersection of these three things about AI and educational data science, developing technology with that, and implementing those technology in an actual working in the school and the university context, such that we can see that how data informed decision making is done in the teaching, learning, or educational context. So in today's talk, what I plan to give an overview in the next 30 to 40 minutes is about some one learning activity. As an example, I will give an overview of that, a specific learning activity, and then we will try to see that how data can be captured in that context. And then if we can capture data, what can be enhanced in the context for the teaching learning experience with that data which is captured. Okay. And while I do that, I will give references to research that has been published to elaborate about how systematically, for one example, how systematically we developed a parallel research theme for each of these development and research, development and outreach work that we were doing. Okay. So I think some of you in this room have already used an online learning system during teaching or learning. For instance, some of you might have used a learning management system or a LMS, such as Moodle, in your educational during your educational period. And then during that time, some of you might have also tracked or looked at teaching activities with the data. For instance, if you are an instructor, you might have seen that how many of your students have submitted the assignments that you have provided, or if you're a learner, you might have checked that how many activities are left, or how much more effort is required to complete a particular online course that you are currently enrolled in, right? And while doing this, sometimes you have also participated either in or conducted group works. So for instance, if you have participated in a think pair share activity in some of the EdTech Society's workshop. Okay, so those are some of the group works that you might have participated. So these are the context in which I would give an example today. And then when we see that educational practice has evolved from being a more traditional one. And I will so traditional means that there is more of a lecturing which is happening, whereas going to a technology enhanced one where technology is used for augmenting some of the things which the traditional one, maybe just in the face to face, was not able to conduct, or to expand that horizon of from face to face to going to scaling it up on that front. But then the third one is where we are actually trying to see that can the data which is captured in an online environment, or data if it is can be captured during a face-to-face session, can that data be used to enhance the practice? Okay, so these are the three level or layers of practices. And often we have now exposed to the technology enhanced layer of it, because we are using a lot of technology, or ICT, or information and communication technology, to actually conduct our teaching, learning, or educational practices. But can we move it to the next tier, where where some of the technologies which enable us to capture the data, uh, can we utilize that data uh, for enhancing our educational practices? So let me start with the example. So if there is this was one of the class which it was in a form of a workshop where we were trying to discuss what is data science. Okay, so typically what would happen in a traditional lecturing? So traditional lecturing, it is more of the teacher is in the front of the class, and the teacher would talk about what is data science, maybe provide some definitions and concepts and examples, and then at the end of the class would provide a quiz, an assignment on the topic. And it can be just a classroom practice, or it can just be so this experience is more of uh, less of interactivity, but the interactions maybe is offset by saying that, okay, go and look at the quizzes or the assignments, and then you can do it by yourself for the students, right? But then what we did in that workshop was we did a draw and write activity. So do you think that it is technology enhanced? Probably I would consider that it is still a native or a primitive pen and paper technology. It is enhanced because it is now trying to gain more interactivity by saying that, okay, let the students construct uh, their own meaning of what is data science. And the activity design was asking them to give a visual representation of what they mean by data science, and to write a statement about what is data science, right? And so that's the first layer. So now to design this activity, it was we tried to implement it from a protocol called I square protocol, where they are trying to say that the pedagogy can be integrated with an art and research, and here it's a draw and write technique which can help them. And for doing that, typically the learning design would involve that there would be a guided question. So in our case, it was the question, what is data science? And then the students or the learners are asked to write a statement about to complete the statement data science is, and then on the flip side of the card, draw what is their impression, or what is their idea about data science, right? Now it was an individual activity, right? Now if you want to make it into a group activity, what can be the next step about a group activity? So if you think about that, what can be the uh, next follow-up after the individual phase where they have written and drawn? So there, as an instructor, we again need to give some guided question, right? So an example of the guided question in this case was what we did was we collected all the cards, the individual cards, we shuffled it, and then again we redistributed by making a smaller group and redistributed a set of cards to those groups and said, can you group the cards and discuss and highlight common themes that emerge from those set of cards? Okay, so then the students started to talk, and then they were looking at the card, they were looking at the pictures and also at the statements, and then try to group together some of the cards and say that, okay, this is the theme that emerges. And then this goes to a share phase where they were trying, while they were doing that, there was a guided question. So they had to say that what are the features that they looked in that card to create the themes. Okay, so typically what the students did was they said that, oh, I looked at the statements, and most of those statements said about X, and that's why X was the theme, and we thought that that was the theme. Some of them actually ignored the statements and looked at only the figures that was drawn and said that, oh, see, most of them drew that there would be a technology which is involved in data science, and we said that, okay, there is this technology component which is important, which is about computing, because everybody had drawn a computer somewhere, and we grouped in together about data science is about computing using machines. Okay, and some of them actually tried to connect both the pictures and the text and came up with that, okay, we have these typical set of representations which talks about algorithms or a flow, and they also talk about there is some kind of mathematics involved, and it is also written that it is for the benefit of the society. So probably data science is for society, to help society move forward with the help of the data. Okay. So in this case, they were trying to articulate what in that card they were looking at to highlight the grouping that they had done. Okay. Now, if you have already done such kind of activities in your class, or if you have experienced these kind of interactive or active learning activities in your class, uh, then you're already there at doing some active learning with group work. Okay, but now today's question is, how can we enhance it, or how can we make it the experience with a data driven approach? So first, let us think about what data can be captured during each phase of the learning experience, the previous learning experience. So I will give you the phases. The first phase was about when the individual was writing or drawing, and the next phase is about when they were doing the group work, they tried to say that what is the theme. And the third phase is about sharing the themes that came up, but while doing that, highlighting what are the features in the drawing or the writing that they looked at for sharing, for coming up with that theme. Okay, so you can take a moment and think about it. If I go and then list it down, so I want to highlight two things. So I will give examples of the first two phases, where in the individual phase, probably the artifacts which are generated. So what is the artifact? That the actual individual's drawing or the text that they are writing is the data that can be collected. Okay. And if you look at the granularity means, if I am capturing, so if somebody just submits the card, what I get is the final output, the end product of that drawing or the full text. Okay, but if we can capture this with technology, probably we can capture the stroke of each of those drawing, or while they were typing in or while they were writing the text, how many times did they edit it? Okay, so that is where technology gives one. So if it is technology enhanced, it might give one layer of more information, so the granularity increases. Okay, similarly, in when we introduce the technology, we can also process that data or maybe say that if there were different drawings, where there's some styles of drawing which were common. Okay, so most of some of them were using, say, a flowchart kind of a representation to say what is data science, or somebody was using a set of emojis, or if they were drawing characters or not. Okay, so there was styles can be processed from the data which is collected. Okay, and on the text side also we can look at the complexity of the expression. So the simple processing can be how long did they write. So it was sent only a statement to finish, but then how long was the statement, right? So those kind of things are what can be processed from the individual data that is collected. Okay, and similarly, for the group work phase, there can be conversations that can be captured. Okay, or we can capture for each of the group what is the theme that emerged. Okay, and here also, if we think about granularity, we can either capture the we can either look at the whole conversation, or we can look at each statement, which group member was saying what statement, and then try to process it at the next level and say that, okay, what is the kind of group dynamics? Who was there, a kind, if there are 4 or 5 people in the group, was there one person who emerges as the leader because they were trying to say more or participate more in that group activity, or were there how many conversation dialogues were there, how many people actually converse with each other. Okay, or on the other part, the themes, can we say that when we look at across the groups, can we say that, okay, there are these common themes that are emerging from there? So collecting data at a group level, we are going to for the whole class level, are there some uh, themes that are emerging from there? So these are the examples of what data can be captured. And I introduced two concepts over here. One is about the granularity of the data, and another is about the processing of that data. Now, if we think about it, so if we are trying to think about data driven services, we have to keep those in mind. And then in any of the activity, try to ask the questions about what kind of data can be collected in that activity, or what kind of insights can be interesting to share with that with the data that is being collected. Now, if you want to go to an insight, what kind of analysis is required to provide that insights? And this analysis part maybe is the technique part of it. Okay, but then there are other set of questions which are about what kind of interaction design is needed, means what is the actual activity design in which the data which is collected can be used for the follow up. Okay, or if we are trying to use the data to evaluate that experience, what are the measures of effectiveness, and how can we track the learner's experience? Okay, that those itself is something which we think about when we think about what is a data driven service. Okay, and now, even as an instructor, if you think about it, so you are doing this group work. Now, if somebody is teaching a data science course, probably every semester or every time they're offering this course, they are doing this group work. But then, as we can capture that, okay, this activity was at this point of time had some difficulties. Okay, so if we can capture some data, and then we can extract that, okay, these are the this in the second phase, these are the set of difficulties. Okay, and then if we can store that and say that next time I do it, I would keep in mind that in the second phase, these are important pointers that I need to keep in mind. Okay, now if some instructor wants to share this practice, how can we capture those evidences which are captured from the data to then create, for instance, a set of design principles that can be shared amongst different instructors who are conducting the course or a similar course. Okay, and then as a data scientist, often we also think about to what extent certain practices can be applicable in another domain. So if I am doing this group work for what is data science as a question, to what extent can this be generalized? And if I say that, okay, you are in a different domain, but you can also apply this set of learning activities in your domain, to what extent can we do that, and can we create a repository? So to do that, there is also a need to think from what kind of data driven services can be created for that. Okay, and here I come to an overview, and I think I experienced a very interesting and engaging panel discussion last time in the EdTech Societies as an activity, where experts from the field of learning sciences were talking about the core of about learning science, and the essence of how we learn is a question that is asked in learning science, right? And I wanted to represent it as a triangle, where we see that learning analytics is to think about what kind of data can be captured and to make sense of that data, which can then also help to answer questions about how we learn. Okay, so with the data captured and the processing of that data, we can answer the question of how we learn. And most of the times, researchers would capture data for understanding, and that's a code of the science. So we capture data and process it to understand how are we learning. But over here, I'm trying to also advocate that from an engineering perspective, it is not just about how we learn, but it's also about how can we make that experience, the learning experience, or engineer a learning experience with the help of the data that we have collected. And that links to the right hand side over here, where we are talking about the learning design, or how we support the teaching learning activity with the data. So this is probably the midpoint of it, and then I will go to examples where I will highlight how learning analytics and learning design and learning sciences are connected. And I will give example of uh, a project that I work with Liang. Liang is now a postdoc in Kyoto University, and I worked with him during his master's and PhD. So over the last 4 years, we proposed a group learning orchestration based on evidence framework, which is the GLOBE framework, where we try to see that how for group learning we can capture data and what can be done with that captured data. So before that, he conceptualized that there are these phases of group learning, so or group work, where we have, as an instructor, we might have to form the group formation part, and then with the group, the group works on an activity. So there the facilitator needs to orchestrate the activity, and after the activity, often the facilitators want a peer evaluation, where the peers of the group or the peer groups evaluate each other. And then there is a reflection phase, where if I am a learner, I reflect on the group work that I have done. And this is in this framework, probably there is a lot of data which can be collected, and Liang and we try to look at what kind of data can be collected for given online learning system that we were using, and how we can utilize that data for a subsequent phase in that group learning cycle, right? So over here, what you can see is probably we can use data to form the group, or we can use data to understand how the group work is going on, or we can use data to say that who is my peer who should evaluate me. So while group formation can have data to say that who are my group mates, the data can also inform who are the peers who would evaluate my work. Okay, and then the data can also be captured for the group work reflection. So if I have a experience reflection like a rating, I might use that captured data for the subsequent group work. So I might use all the data which is captured in the subsequent group work. Okay. So let me give some examples for that. Okay. So here it was trying to do a learning design with learning analytics. So here we have the learning log based automatic group formation, and where we created a system where all the captured data were then utilized to do either homogeneous or heterogeneous groups. So what is the captured data? So this was in the context of an school level maths learning, and they were doing a reading activity, and then they were participating in a group work. So we were trying to see that during the group work, uh, the teacher would give to the system that okay, these are the students who do not want to be paired in a group or part of a group. So they were mentioning to the system which students should not be grouped together. Okay. And then the system handled those exceptions and tried to create a group which satisfied those conditions. Okay. So with that, typically in a Japanese school, there are a lot of group work, and teachers take a lot of time to create the group. And during the class hours, it takes up a lot of their time and effort to creating the group itself. But if there is a system that can say that okay, these students are in group one, then the teacher can just show that on the screen in the front of the class, and the class can rearrange themselves. Okay. So that was one of the activities where we tried to see what kind of grouping can be done with the available data in the school context. And for this, what Liang built was, because they were still not, so there was a lot of things which were done in the physical location. So what he wanted to do is there was an option to upload a data to the system. Okay. Once that data can be uploaded into the system, then the system can be used for making the grouping. Okay. But for the actual group work, to evaluate the group work, there were sets of microphones that were given for each groups, and we were capturing the conversation which were happening between the students or between the kids over there. And with that, we tried to evaluate each of the groups engagement activity, right? So that was again given back to the directly synchronized with the system. So the system could then say to the teacher the engagement level of each of the groups which were there. Okay. And typically for the teacher, they had to go around all these groups and have a sense of that. But over here, the technology driven, data driven services could provide that support to the teacher. Then they could see that how some of the groups can be supported or not. Okay. And in the study, we did a two group design study. Some of the activity, some of the classes, the teachers were asked to create the groups. In other classes, the computer generated the groups and then provided it for the teacher. And we saw that in the students who in the group activities which was generated by the computer, there were more positive emotions. So the emotions that the students reported were also the ones with the computer generated group was also comparable to the teacher generated group. That means that they did not have any negative effects on that group work. Okay. Now, moving on, another example. So, here it was in the college context where the college students were given a text to read. Okay. And when they were reading the text, the students were said that you can highlight portions which you think is important by a red marker, and you can highlight portions which you do not understand by a yellow marker. Okay. Now, each of that was happening on an online PDF reader called Bookroll, where these data were captured. So which of the content was highlighted as important, which of the content was highlighted as difficult, and then as a follow up. So it was a flip design. So the students did the reading at home, and then during the synchronous class they were supposed to be grouped. And it often becomes difficult for grouping it based on what they have done, but because they were given this activity of highlighting, the system could then group uh, students who had highlighted some parts as difficult and those who have not, and could group them together in a heterogeneous manner, where if I do not have I have no doubt in a particular portion, can be grouped together with another student and do a peer instruction where I can try to clarify which part the other learner was having difficulty in. In a similar way, in another context, if there are parts of the text which I feel important are similar, we can be grouped together in a homogeneous manner to see that to what extent can we to or to articulate why do we think that particular portion was important. Okay. So to do this, we tried to do it in so this the algorithm that was developed was the novelty and the types of data that we captured, and implementing it in the system was what was presented over here. And we could see that there was a sense of creating this individual reading after that the group work for facilitating peer instruction, and also to do further discussion which can be supported by the system. Okay. Now, in another context, the similar reading and after the reading context, there was one in the junior high school or middle school level, where in a language classroom, it was a Japanese language classroom, the system was used to group homogeneous and heterogeneous students, heterogeneous groups, and then they were trying to do two different kinds of activities. One was a brainstorming activity, and it's the idea generation activity, and the other was a comparative reading activity. Okay. So there we wanted to do a more of trying to see that what effects. Okay, so it was more from a learning science perspective, trying to evaluate that what kind of grouping is more effective for idea exchange kind of activity, and what kind of grouping was more effective for comparative reading. Okay. And I would leave it for this audience to have a look at the abstract over here to find the answer. But we had found differences between the homogeneous and the random grouping, and between the heterogeneous and the random grouping. So the random was taken as the baseline to see that if we just group certain students according to some of their students some of their attributes randomly, does it does a homogeneous or a heterogeneous grouping affect more than that random. Okay. So that was one of the work. Now moving on to another one, then we looked at how the learning design itself can be supported with the data which is captured. And then we also looked at what kind of questions about what is effective can be answered with the data that is captured. And the third one is more about analytics. So here what we said was there was this the learner model. So what is a learner model? So it's the attributed collected about an individual learner. So the learner model in the pre-phase or the before group work phase could be about their previous scores, or their previous engagement, or their previous skill rating that they had. Okay. And with that, in this activity, the learners were given an option to evaluate their peers, right? And then when they're evaluating it on an online system, so it is like giving a rating. So they can we can see that they were trying to what is their peer rating behavior. So do I give everybody a high rate, or do I take a lot of time to actually review the item and then give different ratings for each of the item that I am rating for. So those were the peer evaluation behavior. So data that can be collected for the peer evaluation behavior is something like the total evaluation time, the number of clicks that they did for changing the ratings or not. Okay. And after the peer evaluation, we can also compute things like the consistency of the evaluation. For instance, if I have given a rating and an instructor has also given a rating, so how near is my rating to the instructor's rating? So we call that as the validity indicator. Versus if I have given a rating and then my other peers have also given a rating, how close is my rating to the average of the other peers? So we called it the reliability indicator in the peer rating, right? Now in this scenario, okay, can we detect who is an unserious rater, versus can we predict that what can be my rating behavior given other data that I have collected before in that context of that course? Okay. So those kind of questions are something which are data driven prediction of learner behaviors. And in an ecosystem where we are capturing all these data in a learning record store, which is LRS, so the available data and the context is there for the system to do these computation or prediction, right? So we had tried to see that to what extent can we detect the patterns of rating, as well as to what extent can we detect the serious raters, serious being evaluated with respect to the validity and reliability of the actual raters. Going more into prediction with the data, we also try to see that given those three phases of activity, to what extent can we, so in this particular context, so the the antecedent where and so I will talk about the indicators over here. So antecedent is the time when we are doing some activity in the pre-phase. So for example, over here, before the group work or before the peer evaluation, so that is the antecedent phase. And during the group work or the peer evaluation, and consequent is after the group work or the peer evaluation, right? So in the antecedent phase, the individual, we can capture in the system the reading time, the completion rate of the given reading material, or the number of markers that were highlighted by that individual, or the number of memos that were taken while they were reading, or the previous rounds peer rating also becomes an antecedent for the subsequent round, right? So the previous peer ratings or the previous teacher ratings of that individual on a particular thing, these are all antecedent before they are doing the actual group work. Okay. And in this context, the actual group work was a forum discussion. So they were doing the number of posts on forum and the number of the length of the post, right? And based on that, they were doing a peer evaluation. So the rating of so they were doing peer evaluation on two aspects. One was about an initiative and about a communication. And also after this group work, they were having an evaluation component for that course. So the final course grade was also as a considered as a consequent indicator, right? So we found what is the correlation between individual level indicators of group work. Okay, so with antecedent and consequent and process. Okay. In a similar way, there were group level indicators for the group work. For instance, this over here, the antecedent for the group level is when we accumulate the whole group's total reading time. So whole group means individual members of the whole group. But for instance, there might be previous peer rating for that group. Okay, so that is the previous peer rating for that group. What those indicators, right? And for the whole group, what is the average forum post and the average of the forum the participation forum activity, the discussion forum length. So those were the process indicators for that group work. Okay, and we could see that to what extent can the automatic group formation, so where the groups are being automatically formed either in homogeneous or a heterogeneous configuration, can and the data is collected in the system, to what extent can we predict these, knowing the antecedent, to what extent can we predict the process or the consequence indicators, right? Now that summed up Liang's overall thing, and we tried to see that what do we understand from these set of studies that we had done over this last 3 or 4 years. So we could see that we proposed that there is this team-based learning approach or the learning design, where the individual learners often gets oriented, so they will know about their overall task, and then they would say that okay, there is an individual preparation phase, and they will know about what they need to do in this group work and peer evaluation. That's the orientation phase. And then typically we had a reading based task where they will do a individual reading, and then they did some kind of pre-group work evaluation or a formative assessment. And based on all the data that was collected, then we tried to do a group, and then the grouping, and with that grouping they did the group work, and after the group work they did a peer evaluation, right? And each of these, the steps in between, they were doing multiple number of times. So in a typical university course, what we did was we had, so if it was a reading based a reading course, then we did this every week. So every week they were getting a reading assignment. They were doing a group work together to present their understanding of that paper, and then doing a peer evaluation. Then they were again regrouped, and then they were doing it again. So the essence is we are not just doing it once, but we are doing it in a continuous cycle form. Okay, and when we are doing it in a continuous cycle form, then the data can be captured and collected, and it can be reused for the next cycle, right? And here we have given examples of what kind of data can be collected. And the important thing is, a system, a data driven service needs to be created to synthesize these kind of different types of data, and then it needs to be utilized. That means there needs to be services which needs to with that synchronized data, needs to create, for instance, form the group, or needs to know that who are my peer evaluators, so do the peer evaluation. Okay, and then we can utilize these indicators itself for the forming the group, and that's the utilization part. And then also analyze. So analyze is the part where we can create predictive models with the data which is there, and try to see that can to what extent can we predict the learner behaviors, or to what extent can we predict the learner performance indicators in a particular group work, right? So again, coming back to here, we try to look at group work and try to say that, okay, we propose the design, which is an iterative team-based learning design, where reading-based activities were there, and then peer evaluation activities were designed, which was supported with the data which is collected in the system. And we could answer questions about how we do group work, or what is a favorable way of doing group work, whether it's heterogeneous or homogeneous in a particular context of learning. And then we can also see that how in the context of analytics, we can see that capturing learner data, okay, or capturing the learner model before, during, and after group work was something that needs to be focused on. And then we can group students based on the learner model that is there, and also predict learner behaviors and performances based on the models that we have captured, right? So that was mainly the part which is there. And it's not that we can only do it at our end. So going forward, what I did was we created a platform where, as an instructor, you can create or author your own activity, and the platform collects the interaction and the artifact data in that system. But you, as a instructor as well as the learner, has access to a dashboard where they can look at what kind of activities they were doing, their artifacts and others artifacts. And then as an instructor, you can also facilitate them to look at how can they utilize their own data. Okay, so it would be a totally different topic, so I probably would leave it there. But if anybody is interested to collaborate and use this platform for their teaching or doing research, you're most welcome to contact me for that. Okay, so this platform essentially has an authoring tool, what I said, where you can author the activity, and then you can, as a learner, they can view it. And then there is a whole dashboard where in the dashboard, the learners can look at their interaction times, they can do the social comparison, and they can also export the data for their further analysis, or you as an instructor can do that. Yeah. So what next? So what I talked about was more about the classroom and the online learning, but I'm also now trying to collaborate to see that can we do this in a physical, to bridge physical learning activity and online learning activity. For instance, can we capture data when there is a physical activity going on, or when somebody is doing playing a game? Can we capture data to inform the next step of coaching with the captured data from a physical sensor, and then utilize that sensor data to do a reflection on the activity, right? There is one more example which I would not include over here, but it is about active reading. And Ms. Toyokawa has done this about how they can use the handwriting, the handwritten strokes captured in the system, to utilize that for an inclusive classroom, or to do facilitation with the teachers in a special needs class. Okay, and we have also tried to do that to identify maths problem. Where do students get stuck when they are trying to solve a maths problem? So these are things which can be possible if we capture the data and then utilize the data to visualize or to predict what kind of things can get when students can get stuck. Okay, there is also a learning design with the drawing activity on an online platform. But I would say that I stop over here and try to say that reflect, if there is one takeaway slide, this would be the takeaway slide where you try to think about what kind of so this is the essence of the thing. So what kind of analytics would you do to inform what kind of learning and what kind of design? So thank you very much for attending this. If you have any questions or comments, I think I am happy to take it now. Okay. So, so while if I have some more time, what I will do is, uh, let me see. So those who yeah, those who are interested, they can go to this LAreflecT platform. So we created this platform, and on the bottom of this there is a form which you, if you can fill up the form, then we can I will give you access, and we can work together to use this LAreflecT platform. Right, let me see. Okay.
Okay, so let me start with the questions posted by the participants. So we have one
Sure.
question from Shrutika. She's asking like, how can educators and technologists collaborate to develop more effective data-driven educational tools?
Wonderful question. Uh, Sunika, thank you for that question. I think the core approach that I follow is, I do not often know what is the root causes or the root challenges on in the context. So I talk with the educators, and then I visit the context, or often if it is an online context, I try to wear the student's hat and then experience what is the current workflow that they are following. Okay, and based on that, what we try to do is try to see again the same set of question: what kind of data can be captured in there, and what kind of activities can be followed up for the educators or the learners to then make it more engaging. Okay, and maybe some of the implicit things that I have is, probably it is not a one step activity. Okay, it's definitely a two step activity, where we do something, capture the data, utilize it in the next step. Okay, so understanding it, I think the important thing is, we collaborate and we co-design, and we understand. So if I'm wearing a technologist hat and say that, oh, I know everything, or I provide a solution because I have this hammer, and then if you have a nail, please use the hammer, it does not work, right? So yeah, essence is communication.
Correct. And so I have few questions related to technology and tools. You have talked about your tools which you are using for data driven, right? Educational services. So what other technologies or tools generally like most commonly used to collect and analyze educational data?
So I would say that it also depends upon the infrastructure. So if an teacher is part of an institution, institutions often have a learning management system, and they would have their policy of handling the data. And with that, the instructor can think about what data is available. So learning management system has data, it often provides you a dashboard, you can look at it, and the key is then, just not, dashboard is not the end of it, so it's more of a middle step. You look at the dashboard, then inform yourself for the next step of activity that you would do, informing with the information that is available in the dashboard. Okay, so learning management systems are maybe more easily approachable, because many instructors have their institutional platforms over there. Apart from that, for instance, individual instructors who are providing, say, an YouTube channel based instruction, they also can utilize Google's YouTube analytics and probably look at how things are going on in their viewership, and then decide what kind of follow up they want to do with that, or create a follow up video based on that. Yeah.
Correct. So LMS, as you said, like actually, like Moodle or MS Teams, that can be used, right? Okay.
Right.
And the main, now generative AI is there everywhere. So, what role does artificial intelligence or AI play in data-driven educational services? Can you just highlight?
So though it's a whole different talk by itself, and I would say that the role of generative AI over here that we are trying to explore right now is, if we have a dashboard, okay, so the dashboard might have a lot of information over there, but as an user it might not be very readily accessible to see what information makes sense for me for my context. Okay, so what we are trying to see that if we can look at a dashboard and link it to a generative AI to give an initial prompts about where to look at in that dashboard, okay, or to say that for the teachers while they are creating these activities, for instance, if there are some kind of formative questions that are required for warm up of a particular activity, to what extent can generative AI utilize that? But again, the key in our research context, what I focus on is the conversation with the AI is important, to know that if an instructor, as an instructor, if I'm trying to create a set of questions for my topic, what was my prompt? Okay, so if I have the instructor's prompt and the answer from the AI, probably I can see, and the next prompt from the instructor for refining it, I can probably look at both of them together to see what was essential for improving that, or what was the prompt engineering that was done. Okay, so those kind of approach essentially means knowing what data needs to be captured to inform what kind of information. Yeah.
Okay, so thank you so much, Tujit. So as we come to the end of this insightful masterclass, I wanted to express my heartfelt thanks to everyone for their participation and engagement. My sincere gratitude to Dr. Ritujit for accepting our invite and for sharing his valuable insights and expertise with us. So your contribution have enriched our understanding and inspired us to reflect on the data-driven services for technology-enhanced education. Thank you once again. A successful conduct of this event wouldn't have been possible without the strong support and guidance of our mentor, Sridhar Iyer sir, Biju sir, and Lakshmi Ganesh. Special mention to our technical team members Vivek Sabanwar, Nagesh Pokle, Sandeep Yadav, and Ramdas Rai for their invaluable efforts. Thank you, everyone. And to our participants, thank you for your active engagement and thoughtful questions. Thank you once again for being part of this masterclass, and we look forward to your participation in our future events too. I wanted to make few announcements for the participants. You need to attempt the quiz and fill the feedback form, which will be available in your EdTech Society dashboard after you log into your account to get the certificate for this masterclass. Thank you once again for being part of this enriching experience. Thank you,
Thank
everyone.
you for having me. Thank you very much.
Thank you.